Good. We are keeping the machine human. Keep the machine human. Why is it? This is a one person has got. People have joined me. People have joined. Let's see. Where's the line spoken? Has anybody able to join? Okay, we are going to start soon. We are going to start soon. People have joined. Okay. Sorry for the delay. Okay, people are outside. They joined. Class, in the last class, we look at types of compound. In the next 20 minutes, we are going to conclude this so that the staff student can have mathematics. In the next 20 minutes, we are going to conclude this so that you people can also rest. Types of compound. I told you that the first one is what? Ionic compound. And I've given you the meaning of ionic compound. Another name for it is what? electrovalent what? Compound. And I said the second one is what? Molecular compound. Molecular compound, which can also be called covalent, which you are common with. The third one, I said intermetallic compound. It has no common name or other name. And we have coordination compound. Coordination compound, which is very important. It's an important compound. You can also call it dative compound. Coordination compound. Okay, class. Let's look at intermetallic compound because we've done the covalent compound and ionic compound. Right, intermetallic compound. Intermetallic compound. Intermetallic compound. Right. These are compounds. These are compounds. These are compounds that can be formed by the combination of two or more metals. By the combination of two or more metals. By the combination of two or more metals. These are compounds that are formed by the combination of two or more metals in a fixed stoichiometry ratio. In a fixed stoichiometry what? Stoichiometry ratio. In a fixed stoichiometry ratio. Or you can just say in a fixed ratio. In a stoichiometry what? Ratio. That means when you have two or more metals coming together to form a compound, it's known as intermetallic compound. When you have two or more metals coming together to form a compound, it's known as what? Intermetallic compound. And what kind of bond or what is intermetallic compound? Most people will say it's metallic bond. Yes, you are right. But it's not only metallic bond that occur in intermetallic compound. Other bonds also occur in intermetallic compound. Bonds that formed in intermetallic compound you can have metallic bond in it, metallic bond, which is the common one. Then they can exhibit what? Covalent bond also. Intermetallic compound can exhibit what? Metallic bond and covalent bond. Intermetallic compound can exhibit metallic bond and covalent bond. And also ionic bond. Ionic what? Bond. Take note. Intermetallic compound can exhibit 3 bonds at the same time or 2 bonds at the same time. It's not necessary they have only metallic bond. They can have metallic and covalent bond. They can exhibit metallic and ionic bond. They can exhibit only metallic bond. It depending on the what? On the metals that combine. That means intermetallic compound does not only have 1 bond. Not like ionic compound that has what? Only ionic bond. Not like a molecular compound that have only what? Covalent bond. Intermetallic bond can exhibit 2 bonds. They can have metallic and covalent bond. They can have 3 bonds. Metallic, covalent, and what? Ionic what? Bond. Take note. Then what are examples of intermetallic bond? Examples of intermetallic bond. Examples of what? Intermetallic bond. We have nickel aluminide. Nickel aluminite, nickel aluminite. We have titanium aluminite, aluminite. We have titanium aluminite. We have copper gold. That is metals. Where you have two or more metals. Copper gold. We have copper gold. We have magnesium aluminite. Magnesium aluminite, etc. Just combine two or more metals. That is intermetallic compound. And they are very useful in constructions. Especially aerospace engine. In aerospace engine, we use what? Titanium aluminite. In aerospace engine, they are very important. Take note of that. Take note of that. Let's go to the last one, which is coordination compound. The most important, one of the most important. Coordination compound. Hope you people can, those who are online, hope you are following. The sound is breaking. Someone said the sound is breaking. Let me test. Let us test from our end. What about this? Like this? The sound is okay. I'm testing. The sound is okay. It's okay from my end. The sound is okay. The sound is okay. Sissy said the sound is breaking. Please, maybe check your network. If there's any other person, that is having the same issue, please, the person should identify. Please. Okay, someone said I should explain intermetallic. CC, can you hear us clearly now? CC, can you hear us clearly? Please, if you can hear us clearly, please identify. Please, thumb up. Someone said I should re-explain intermetallic compound. Listen, intermetallic compound, it is formed by the combination of two or more metals. When you have two or more metals, combined, these are two metals. When you have, nickel is a metal, aluminum is a metal. I will explain. Some of you are not familiar with this metal, nickel, titanium, copper, gold. These are transition metals. I will talk on them under coordination compound. Transition metals. I will give you an example of transition metals. Don't worry. When we get to coordination compound, take note. Intermetallic compound is a combination of two or more metals. When they are combined in a fixed ratio, can you see 1:1? Nickel is 1:1 of aluminium. Titanium 1:1 to aluminium. Copper, how many ratio of copper? 3:1. Copper is 3. Gold is what? 1. 3:1. Magnesium here is what? 17 to what? Ratio what? 12 of what? Aluminium. They combine in a what? Fixed ratio. That is intermetallic compound. When you have two or more metals combine it together in a fixed stoichiometry ratio, or you can say in a fixed ratio. When two or more metals combine in a fixed what? Ratio. Combination of two or more metals in a fixed ratio. Combination of two or more metals in a fixed ratio. That is called intermetallic compound. And the kind of bond that occur in intermetallic compound is not only metallic bond. You can have three bonds occurring in them. You can have only one bond occurring in them. These are bonds that can occur in intermetallic compound. Metallic bond can occur in intermetallic compound. Covalent bond can occur in intermetallic compound. Ionic bond can occur in an intermetallic compound. Three of them can occur at once in an intermetallic compound. Three of these bonds can occur at once in an intermetallic compound. Two of them can occur at once in intermetallic compound. One of them, which is metallic bond, can occur only in metallic compound. Take note. Then these are examples of intermetallic compound. You see, metals, they are all metals combining together. That is intermetallic compound. What? Characteristics. I'll give you. Right. Characteristics of intermetallic compound. Characteristics of intermetallic compound. Characteristics of intermetallic compound. Characteristics of intermetallic compound. Thank you for that. Characteristics of intermetallic compound. Number one, they conduct electricity as a metal. They can conduct electricity as a metal. They can conduct electricity as a metal. Number two, they can conduct electricity as what? Metal. Number two, don't cram it. You know, metals can conduct electricity. That means intermetallic compound will be able to conduct what? Electricity. Don't cram their characteristic. Number two, metals are heavy. You know that? Metals are heavy. That means they have high density. Write it down. They have high density. They have high density.
What about their favorite family?
That is what we are going to now. They are not. They are not. They have high density. Thank you. They are not. They have high density. That means they are heavy. High density. They have high density. Number three, since they have high density, they have high melting point and boiling point. Right now, they have high melting and boiling point. They have high melting and boiling point. Those people online, hope you can follow. Hope you can follow. They have high melting and boiling point. Characteristic of intermetallic compound. They conduct electricity as metal. They have what? High density. They can do what? High melting and what? Boiling point. They have high melting and what? Boiling point. They are solid. Number four. They are solid in physical state. 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 Their physical state is what? Solid, since they are metal. They are solid in physical state. Thank you. They are solid in physical state. Let's go. The next compound, which is the last one. Which is the last one before the start class. Which is the last one. Which is the last one. Very important. Take note. You take note of this. Take note of this compound. Coordination compound. Coordination compound. Which can also be called complex. Complex compound. Complex compound. Take note. Coordination compound. Which can also be called complex compound. Which can also be called complex compound. Which can also be called complex compound. Coordination compound, which can also be called complex compound. Oh, you can get the meaning of intermetallic compound now, please. If you can get it, drop in the group that Tom give, okay, sir. Just say, okay, I can get it. Intermetallic compound. You will do that. Okay, let's move. Coordination compound. Coordination compound. Please listen to this. Coordination compound. Coordination compound. Right. This is a compound formed when central metal atom or metal ion combine with ligands. With ligands. With ligand. With ligand. Okay. With ligands. How will I explain? With ligands. This is a compound form when central metal atom or metal ion combine. Let me combine with what? Ligands. You have to know the meaning of ligand. What is ligand? Ligands. Ligands. Right, ligands. 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 You will know them, don't worry. Ligands. Ligands. Are we set? Ligands. These are ions or molecules that donate one or more lone pair electron to central metallic atom or metal atom or metal ion. Take note. Ligands, they have SL lone pair electron to donate. If they ask you, what is ligand? These are ions or molecules that have excess lone pair electron to donate to central metal atom. Ligands. They have excess electrons, excess lone pair electron, excess to donate. They donate what? Lone pair electron to what? Central metal ion or central metal what? Atoms. That is ligand. And what are the examples of ligand? Example of ligand. We have water is an example of ligand. It's a word neutral ligand. Neutral ligand. Neutral. Water is an example of ligand. Water has excess lone pair electron. You have done bonding in secondary school SS1. That means if you like water, this is water. This is structure. Water. These are excess lone pair. Water has what? 2 lone pair. This is 1, 2. He has excess lone pair to donate to central metal ion. Water is what? Ligand. He has excess lone pair. When you see this is lone pair. This is 2 electron, which is 1 pair. Another 2 electron, 1 pair. That means he has 2 excess what? Lone pair to donate. Another example, ammonia. Ammonia is an example of neutral ligand. Neutral. This is ammonia. Look at ammonia. This is ammonia. That means he has lone pair, SS, lone pair, 1. It's an example of ligands. Ligands. We have another example. Let me know, please. Those people online, you can quickly write them. Water is an example of Lingard. What's that? Okay, space. Water is an example of Lingard. We have phosphine. Phosphine is an example of neutral Lingard. Neutral. This is phosphine. 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 It's an example of neutral what? Lingard. It's an example of what? Neutral Lingard. We have chloride ion. This one is for negative Lingard. Negative Lingard. Negative. We have ozonium.
Okay.
This is negative what? Lingard.
Positive.
Oh, positive. I'm sorry. May God bless you, darling. You are following. Positive. Lingard. Lingard. Positive Lingard. We have etc. So many etc., polyethylia, aquaethylia. Hope you people can understand. You are following. Okay, let me have this. You have cyanide. Cyanide. Yeah, cyanide. Cyanide. The symbol is Cn. Like this, cyanide. Is what? Negative Lingard. Negative Lingard. Negative Lingard. Cyanide. That one is common. Cyanide. Negative Lingard. Cyanide. Negative Lingard. Lingard are ions or molecules. Ions, can you see? They could be ions or molecules. Neutral are molecules. These positive, negative, they are ions. They are ions or molecules that have excess lone pair electron to donate. Don't cram it, please. Please. These are jam questions. Lingard. They are ions or molecules that have excess lone pair electron to donate to central metal atom or central metal ion. They are Lingard. They have excess lone pair electron to donate to central metal atom or to donate to central metal ion. Take note, Lingard. And I've given you example of what? Lingard. Take note of that. Take note of that. Let's move. Then take note. Take note. If they ask you, the central metals or the central metal atom or the central metal ion in coordination compound are mostly transition metals. Transition metals. Take note. Write it down. The central metal atom or central metal ion in coordination compound. The central metal atom or central metal ion in coordination compound. The central metal atom or the central metal ion. The central metal atom or the central metal ion. That central metal atom that we are talking about, the central metal atom or metal ion in coordination compound are mostly what? Transition metals. Are mostly transition metals. Are mostly transition what? Metals. Are mostly what? Transition metals. Class, JAM 2024. And it came out in Japan also 2025 last year. Why does transition metal form coordination compound? Write it down. Why do transition metals, take it down, why do transition metals form coordination compound? Why are they the central metal ion? Why do transition metals form coordination compound? One, they have vacant orbital. they have vacant orbital. They will ask you, why do transition metals form coordination compound? Number one, they have vacant orbitals. They have vacant orbital. Number two, they have variable oxidation number. 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 They have variable send. If you have technical issue, please, you can let us know. If you have technical issue from your side, please let us know. Please let us know. Number three, they have high charge density. 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 This is a topic. Charge density. A vital topic in chemistry, but it's for A level. They have a high charge density. Number four, they form stable complexes. 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 Please take note. If they ask you, why do transition metals form? Then what are transition metals? Shall I drop this one now? Some of you don't know transition metals. Then we could give you transition metals. I'll give you examples. Some of you don't know transition metals. And you have to know that. You should have known it. You should have known it. But don't worry, it's not your fault. Transition metals. What are transition metals? Right. Transition metals. Transition metals. Transition metals. Transition metals. What are transition metals? They are found between group 2 and group 3A of the periodic table. They are found between group 2 and group 3A of the periodic table. This one came out in my head. Which metals are found between group 2 and group 3 of the periodic table? They are our transition metals. Another thing, they start from period 4. Period what? 4. Period 4 of the periodic table. Of the periodic table. They start from period 4 of the periodic table. They are found between group 2 and group 3. And they start from period 4 of the periodic table. Another thing, they are known as D block element. Write it down. They are known as D block elements. Very important. They are known as D block elements. They are known as D block elements. If they ask you, which of the following element is known as D block element? The answer is transition element. That is transition metals. They are known as D block elements. Next one. They have variable oxidation states. They are variable oxidation states. They are variable oxidation states. Next one. They are variable oxidation states.
They are metals and metallic properties.
They are what?
Metals and metallic properties.
Yeah, they have metallic properties.
Yeah.
They form colored compound. Yes. They form colored what? Compound.
I also form pigments.
Yes, I've given you that's why they form colored compound. They form colored compound.
So, they're also paramagnetic.
Yes, yeah. But not all of them. There are some that are ferromagnetic. Copper, iron, nickel, they are ferromagnetic. That is physics. Don't let us go to that. That's physics. Ferro. The best ferro, iron, nickel. Ferromagnetic. Okay. They form colored compound. Take note of that. Then, what are the examples of transition metals? What are the examples? Examples. Let me give you examples. We have titanium. Titanium. We have scandium. We have CO. C small letter O. Cobalt. We have Ni. Nickel. We have Zn. But sometimes zinc is not. When we get to advanced chemistry, I don't regard it as what transition metals. But at this level, because they are fully d orbital. Transition metal, they have what? They don't have fully filled d orbital. But this one has fully filled d orbital. But at this level, I can still count it. But in advance, I will change it for you. Zinc. Let me put zinc. I have iron. I have Cu. Copper. I have chromium. See how? Chromium. I have the vanadium. These are the first period 4. Vanadium. I have Ag, silver. Au, gold. I have Ag, mercury. What? No, that is group 4. Tin is group 4. These are common one that you have to know. The common one you have to know at this level. The common one you have to know at this level. Take note. If they ask you which transition metals is also known as liquid metal, Mercury is an example of liquid metal. Liquid metal. Take note. Liquid metal. Mercury is an example of liquid metal. Take note.
So is that the only liquid metal?
Yeah, we have calcium can occur as liquid metal, but this is the most example. Liquid metal. Are we set? Right. Note. Note. The bond that occur in coordination compound. The bond that occur in coordination compound. The bond that occur in coordination compound. The bond that occur in coordination compound is coordinate bond. Coordinate bond. And another name for coordinate bond is dative bond. Dative bond. The bond that occur in what coordination compound is what coordinate bond or dative bond. 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 Then what are examples of coordinate compound? Let me give you examples of coordination compound. The bond that occur in coordination compound is what? Dative bond or coordinate bond. Take note. The bond that occur in what? Coordination compound is dative bond or coordinate bond. Take note. Okay. Okay, let's move. I said the bond that occur in coordination compound is what dative bond or coordinate or bond. Then what are examples? Examples, yeah. Example of coordination compound. Cu NH3 for 2 plus. The name of this is what? Amine copper 2 ion. This is an example of what? Coordination compound. Example of coordination compound. We have, can you see the central atom is what? Copper. The ligand is what? Ammonia, NH3, ammonia. How many ammonia do we have? 4. We have what we call coordination number. Under coordination compound. But at this level, we don't need that one. They say, what is the coordination compound? Coordination number of this. But you don't need that one now. The central atom is what? Copper. The ligand is ammonia. We have 4 ammonia. Another one we have iron, cyanide. We have this. The name of this is what? Ferrate 2 ion. Ferrate 2 ion. 2 ion. Is when you see this kind of compound and they ask you what kind of bond occur in there, the answer is what? Coordinate bond or dative bond. When you see this kind of compound in JAM, they give you this kind of compound and they ask what kind of bond occur in it. The answer is what? Coordinate bond or dative bond. These are examples of a coordination compound.
I also call it dative compound.
You can but you call it complex compound. Take note of that. Hope those people online, hope you are following, please. If you are not following, please let me know. If you are following, please let me know. Please. Take note. Then let's move to the last one for today. Characteristic of coordination compounds. Characteristics of coordination compound. 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 Number one. Characteristics of coordination compound. Number one. Characteristics of coordination compound. Characteristic of coordination compound. Number one. They form compound, or they are colored compound. Number one, they are colored compound. They are colored word compound. They are colored word compound. They are colored compound. They are colored compound. Number two. They show magnetic properties. They show magnetic properties. Why do they show magnetic property? Because of the transition metals. Because of the transition metals, copper, iron, gold, silver, cobalt, chromium. They show magnetic property. Number three, they are fixed coordination number. Coordination number is a topic on its own under this, but O level you don't need it, even in JAM. But for JUPEL, Cambridge A level, you need it. But for JAM, you don't need it. They have fixed word, coordination word, compound. No, coordination word, number. They exhibit isomerism. Number four. They exhibit isomerism. They exhibit isomerism. Let me give you the last one. They exhibit isomerism. Next one. They have specific geometric shape. Number 5. They have specific geometric what? Shape. Number 5. They have specific geometric what? Shape. They have specific geometric shape. Number 6, let me give you 6. They form stable complexes. They form stable complexes. Let me add one. Number 7. They contain ligands. You can add as many. They contain what? Ligands. Please take note of this. That means now you know the meaning of our coordination compound. But coordination compound is a topic in A level. Because we have coordination number, we have ionic sphere in it, we have isomerism, naming of it. The way you name this one is different from the way you name your normal compound. We have naming of it. It's a topic on its own, which you will do in what? A level. But now you have to know the meaning of ligand, coordination compound, normal at this level. But when now move to A level, you know more about it. Please, at this moment, let us call it a what? A day. Please, for UIUS data analysis, software development, cybersecurity, DevOps, please don't forget to contact us so that we'll give you the best. The number is 08080408579. Mr. Tosin, aka Jama, aka. For the SAS student, please wait for your class. Please wait for your mathematics. SAS student, just SAS student. May God be with you and help us all. I see you when we see me, when I see you, when you see me. Take care. I know myself. Ay,